Did I not call anyone? All right. Announcements. So homework 1 is, oh, it's due on Thursday. I moved the deadline 1 day, due Thursday. All you have to do is just either type up your answers or take a picture of your answers, and you can submit them through my classes. All right. Next, we have a quiz on Friday. So I give weekly quizzes on Friday. Pretty small quizzes, should take about 10 minutes. I'll give it to you guys at the end of class on Friday, and we'll do some review on Wednesday too. Okay. Topics that I think we'll be on is interpreting pie charts and creating stem and leaf plots. We'll talk a little bit more about that today. All right. Any questions on homework and quizzes? All right. Okay, so let me change this screen share to a PowerPoint. All right, just a refresher on last class. We're talking about how we represent things called qualitative data. Okay, so there's 2 types of data: quantitative, qualitative. Does anyone remember the difference between the two? Alicia? Yes. Quantitative has to do with. Yeah, right. So quantitative is measurements. Qualitative is more of the categorical ones. You can describe these using words instead of numbers, right? So here we have a bunch of qualitative data. Our goal in the end is to create a bar graph. Okay, so we have a bunch of different types of credit cards: Discover, Visa, American Express, MasterCard, things like that. And on Friday at the end of class, we made what was called a frequency chart, right? Which is basically something that tallies how many things are in each category. So we went through and we counted all the MasterCards and found that there were 11, which is why 11 is next to MasterCard. We found that there were 23 Visas, 9 American Express, and 7 Discovers. Okay, we all up to speed where we left off. Okay, so I'm going to turn this off real quick because I think it might be easier to understand how to make a bar graph without having the PowerPoint pieces. So let's turn our guided notes around to the back of page 1. You'll see graph paper. Okay. We want to make a bar graph. I'm pretty sure everyone's seen a bar graph, but there's some things I want to point out when we're making it. Okay. So let's see. We have a graph. I'm not going to be too picky about this, but sometimes we want to make a title, right? So I guess the title describes what we are explaining. So credit cards, right? So I'll just write on top credit cards. Okay. Then we have 2 different axes. What I'd like you to do is just draw a line towards the bottom of your graph and draw a vertical line towards the left-hand side. And these will be our axes. Okay, so we want to show how much of each category there are. Okay. What normally happens is on the bottom, we're going to write whatever categories there are. So in this case, the type of credit card, right? And on the vertical axis, or how high the bars go, represents how many or like the frequency of things that happen, right? So, all right. One thing I want to know about bar graphs is we have bars, but they're not supposed to touch. Okay, and that's really important because there's going to be another type of graph where the bars do touch. Okay, so make sure the bars don't touch. So we want to have 4 categories, and we have a bunch of these lines. What I'm going to do is kind of space them out a little bit weird. I'm going to count maybe 1, 2, 3, 4, and have the 4th line represent MasterCard. Then I'm supposed to fit 4 things on the bottom. I'm gonna hop maybe like 5 over. 1, 2, 3, 4, 5, and make this the visa. Okay. Then I'm gonna hop over maybe 5 more. 1, 2, 3, 4, 5. American Express. And then maybe hop over 5 more. 1, 2, 3, 4, 5, and make that Discover. Why did I hop over like 5 times? Why didn't I choose like 1 time? Yeah, I wanted them to be equally spaced out. Good. Like I don't want them to be too close together, and I also don't want them to be like have one be like 3 away from the next one, and then the other one be 10 away from the other one. I want them to all be equally spaced out. So I thought 5 was a good number. All right. Looking at our y-axis, we have a bunch of blocks here, and our highest number is 23. So we have to make sure that we have enough y-axis space to put all our bars, right? Let's think about this. Maybe I should make each like second line represent a number. Okay. What would be a good number for this second line to represent? 5. And why did you pick 5?
Sir, do you remember that it's the fact that 7 and 9 concern?
Yeah, it would like space out the numbers pretty good. It also like wouldn't squish all the numbers to the bottom, and it's not too small where there wouldn't be enough space up top, right? So how about this? 5 and 15. That seems pretty good, right? We have enough space to show our bars and the differences between all the heights. Okay, MasterCard. So MasterCard has frequency 11, so that means it must have height 11, right? So I'm going to go to my type. 11 is about here. So the height of this rectangle is going to be 11, right? And I'm just going to make the rectangle like 2 blocks wide. So that's MasterCard. Visa is 23, right? So let's see. Maybe it goes up to here. American Express goes up to 9. So that's like, if I'm drawing this really bad, I'm sorry. And Discover goes up to 7, right? Bad. So we made a bar graph, right? There's spaces between the bars, right? And each of the heights represents how many are in each category, right? So looking at the bar graph, what has the highest amount of frequency? Visa, right? One other thing that I could ask you is, without looking at the chart or the tally chart, how can I figure out how many data pieces there are?
So like if there wasn't a number at the top of the bar, you just have to pick one at the top.
Yeah, right. And I like how you said there's a number on top of the bar sometimes. So for example, I could just read this graph and be like, oh, this bar is height 10. So the frequency of MasterCard, oh, sorry, it should be 11, is 11. If I drew it right, it would be 11. You can do the same thing with these. American Express and Discover. And the total number of values that were taken is just the sum 11 plus 23 plus 9 plus 7 and 50. Okay. Any questions on bar graphs? All right. Let's do a little harder one. Pie charts. Okay. These are a little harder because there's kind of a weird discrepancy between the proportion and the angle that's made. Okay. Okay. here's what we're gonna do. Let's make a chart. And yeah, let's fill out the chart on the front of page 2 first, and then we'll talk about it. Okay. So we got MasterCard, Visa, American Express, and Discover. Okay. So this is the type. We already know the number of observations using our tally chart, right? So this is the number of observations. We had 11, 23, 9, and 7. Let's talk about the proportion. Does anyone know what a proportion is? Like a ratio, right? Or like a fraction. What fraction of the whole is MasterCard? What fraction of Visa is, what fraction of the whole is Visa? What fraction of the whole is Discover? Okay. Any ideas on how to find the proportion?
You just put like for your MasterCard, like 11 over the
Yeah, 11 over the total, which is 50. Okay. Now we know the total is 50 because we can just add up all the observations, right? 11, 9, 7. That's equal to 50. So in order to find the proportion of something, we take the number of observations and divide it by the total, right? In this case, 11 divided by 50 is 0.20. Okay. So we have an equation here. Proportion equals the number of observations over the total, right? How would I find the proportion of Visa? 23 over 50, right? And if you do that in your calculator, you should get 6. Yeah, I'm not going to ask the next ones, but you get 9 over 50, 7 over 50, which gives us 0.18 and 0.12. Any questions on finding the proportions? Yeah, our goal in the end is to make what's called a pie chart, which is this big circle, and they're going to be like little angles. Now, the problem with the angles is they don't correspond to the proportions. We have to do a little bit of math to find out what this angle is and what that angle is. Okay, you can't just say it's equal to 22, 46, 18, and 24. Okay. But we do know what proportion of the total amount of angles there are for each of these, because they're the same as the proportion of the whole. Okay, I'm going to do a little quizzing here. Does anyone know how many angles there are in a whole circle? 360 degrees. 360, good. If you don't remember it, there's that one song that says did a whole 180, and you like go halfway through the circle. And if you wanted to complete the circle, you would do 180 again, right? So it's 180 twice, and it makes 360. Okay, so a whole circle has 360 degrees. Okay, so if we wanted to find the angle in a pie chart, we would take the proportion, which is the percent out of the whole that we have, right? And multiply it by 360. Okay. So how would I find MasterCard? The angle in the circle. Good. 0.22 times 360. I'll do the math for you. You get 79.2. Okay. What about Visa? Do the same thing, right? 0.46 times 360. And that gives me 165.6. Okay. If I were to do, I keep wanting to say American Eagle, don't know why. American Express, I
to 0.18 times 360.
Okay, and that gives me 64.8. And discover could be 0.14 times 360, which gives me 50. So these individual angles are the angles that go inside the circle. We're gonna have a little bit of fun. I'm gonna do something that I don't require you to do in a test or quiz or anything because you don't own these funky guys, okay? But I do think it's kind of interesting to see how we make a pie chart, even if it's not linear. I'm gonna do my best to draw a circle that looks like a circle. Pretty good. Okay. Okay, so there's a circle on the back of, or the front of page 1, right? What I want you to do is draw a dot in the middle of the circle. Okay, that is not the middle. Okay, now what I want you to do is you can draw a line anywhere you want in the circle, but I'm gonna draw it right here, okay? You don't have to draw it there, but I kind of like doing it this way. This is where these guys come in. What we're gonna do is we're gonna draw an angle of 79.2 to represent MasterCard, okay? And how we do it is we take our protractor and we're gonna line this little line where the circle is. Okay, first of all, we're gonna put the dot right where our dot is, okay? And we're gonna line that line that comes out of the dot right along the line we just drew. Okay, so it's just like this. Yeah. Oh, I'm sorry. Here you go. Okay, now if you look at your protractor, there are numbers on the outside and then there's numbers on the inside. We want to look at the inside ones because they start from 0 and go up, and the increases and go up. Okay, so we've got 0, and we're going to go on the inside and look where it says around 79.2. So that's around like right before the line that says 80. Any questions on found that number yet?
At the bottom.
Yeah, like the ones on the inside. Okay. Just draw a dot above where you see that. Okay. Now we're gonna take the protractor off your paper and we're gonna take the straight edge side or straight edge line, straight edge side of our protractor and line up the middle dot and the dot you just drew. Okay. Now we're just going to draw a line and complete our angle. Any questions on making this angle here? All right, so what I just did is I drew an angle whose length is 79.2. So that's the angle inside the circle. Now we're going to label what this means. Well, this whole area of our pie chart represents MasterCard, right? And we're also going to write not the angle, but the proportion inside the pie chart. So it tells people what percentage or proportion of the whole is. So I'm going to write 0.22, or you can write 2%, which is just taking the proportion and multiplying by 100. Okay. So what goes inside isn't the angle, it's the proportion. Okay. Now let's do the next one. Visa, right? Instead of aligning the protractor along the first line we drew, we're going to align our protractor along the second line we drew. Okay, so our protractor is going to be a little bit angled. Okay, our angle is 165.6. So let's just find 165.6, still looking at the inner angle, and draw another dot, 165.6. So it should be really close to that number 170 on the inside. Any questions so far? All right, finally, we're going to draw an angle. Like that. Ooh, that's hard. All right. And of course, we're going to label it these up. And we're not writing the angle, but the proportion. So 0.46 or 46%. Do the same thing with, American Express, not American Eagle. Align our dot and our line with the last line that we drew. Look on the inside for the number. I really need a bigger protractor for the board. We're going to look for 64.8. And connect our line like so. Ooh, that was really good. Okay. Inside American Express, 18%. When we get to our last category, we don't really have to do anything, right? Mainly because this angle is what's left, right? So discovered, don't really have to measure on anything. You should get 15%. Kind of difficult, right? I'm not going to require you to actually measure this out, mainly because there's so much room for error doing this that it doesn't really matter if your angles are really correctly drawn or not, as long as you're not drawing like a huge angle to represent a small one. Okay? Any questions on how I made this pie chart? All right, what we're going to do, I want you to flip over to the back of the second page. There's a very similar example here. It's a survey on my friend's favorite type of movies. I want you to fill out the chart and also try to make a pie chart. All right, and I'll be around the time. Angle and proportion answers on the board. I'm asked to write up the proportion. What's your name? Sorry, Erica. Erica, I asked you to write up. Do you want to explain how you like found the proportion stuff?
Yeah, well, I found the total of observations by adding them all together. So 4 plus 5 plus 1 is 10. And then to find the proportions, you divide the number of observations by.
Awesome, right? So 4 by 10, 0.4, and so on. And I think I got Jasmine to write up the angles. Can you explain how you found the angles?
I took the like 0.4 times and times it by 360 and
Awesome, right? Multiplying each by 360. So good job. We got angle of 144, an angle of 180, and an angle of 36. I'm not going to ask you to come up and draw the pie chart, but it should look something like this. We've got something like this being the comedy, and it should say 40%. This should say action, which is around 50%. Then the last one, drama, should be around 30%. Any questions on how I got the pie chart? Oh my God. All right. Any questions on the pie chart so far? All right. Let me boot up the projector real quick. There's a couple more things I want to talk about with this section here. Hopefully this boots up soon. Share the screen here. So we went through pie charts like that. I think it's booting up, which is good. Remember, I put that eraser. All right, so sometimes it's we're not asked to create a pie chart, but we're given a pie chart and we're asked questions about what the pie chart is telling us. Okay, here's an example. We have 1,200 students enrolled at middle school, and below is a pie chart of the activities the students participate in. So Some of them do sports, some of them do clubs, some of them do hobbies. And according to the graph, we want to see how many of the students participate in sports. Okay. Before we go and think about the question, remember that these numbers here aren't the angles, they're the proportions. Okay. Or in this case, the percents. Anyone have a hunch on how to solve this? Emma K. Emma S. Yes.
1,200 divided by 38.
1,200, really close. So you recognize that you have to take 1,200 and somehow divide it up into like each of the different categories. And dividing by 38 is a good idea. I see another hand up. Did you have an idea?
Yeah, it's 1,200 times 0.38.
Yeah. Okay, so dividing by 38 was the right idea, but unfortunately 38 or 38% doesn't really translate to something over 38. Okay, 38% is actually 38 over 100, okay, which is why we take 5. But over here, we multiply the total times the proportion, which we got from the percent, right? 38% is 0.38. So let's just do that multiplication real quick. We get 0.38 times 1,200. We get 300. So 300 students participate in sports. Any questions on how I got this answer? All right, tiny question. I'm going to give you a couple minutes to work on this one. How many students participate in clubs? All right. How do we find how many students participate in clubs? What do we multiply?
125.
Yeah, the 1,200 times clubs, which was 0.25. I got 0.25 from 25%, right? So when you multiply these two together, oh shoot, I think I wrote down the wrong number. Yeah, 1,200 times 0.3 is actually 456. Sorry. There we go. And we get 300 over here. Anyway, any questions on these two? Yeah, thanks for my pointing out what I didn't even realize that. Okay, let's flip our page over again. We're going to talk about a different type of graph. It's actually a type of bar graph, and has a special name. Does anyone know what it's called? Not quite. Pictograph, right? Pictograph because it has pictures, right? So instead of using bars, sometimes we'll use pictures. So by looking at this graph, how many students take the bus? 7, right? Because, okay, it's right next to it, but 1, 2, 3, 4, 5, 6, 7. So sometimes we can use pictographs. It's a little bit easier to look at. I don't really know if I would choose it over a bar graph in those situations, but it does kind of represent information a little bit nicer, nice to look at. And every single picture represents one unit, right? So one student, one thing, one frequency, something. Let me take a look at this pictograph here. Now this one has pictures. It's definitely not a graph, but it doesn't really represent the information very well. Can anyone see why?
It doesn't actually say the amount of what is sold, it just is kind of thrown on there.
It actually does, but it does it in a weird way. So what's the amount sold last year? 6,000, right? It's kind of like the size of this box. What about this year? 3,000. So I guess in looking between last year and comparing to this year, yeah. Oh, sorry. Oh, yeah. If we compare these two, it looks like this year we only saw half the jumps through this year than last year, right? But what does this graph kind of make it look like? That is less than a half, right? This picture, the problem what they do is they kind of like, if you ever use PowerPoint and you're trying to like reduce the size of the image, they like took a corner and like drug it down, which means that they decrease the proportions of both the length and the width of the picture, right? So this picture isn't half the size of this picture. It's actually a quarter of this picture. Okay. So pictographs aren't really good when you're putting them in like a bar graph, and we're like putting the picture inside of the bars. Not a very good representation of our information here. Okay, so there is a danger to pictographs when they look like this. You just have smileys in front of different categories. I think it's okay. But when we're like reducing the size of the pictures, things can get a little wonky. Okay. Yeah.
This pictograph can be turned into a pie chart.
Come on. I never see. I actually kind of want to look that up. I never really thought about that. Huh. I think you can, but I can't imagine my head would look like it. I want to look it up. Yeah, that's a good question. All right. Any questions on like pictographs, pie charts, bar graphs, anything like that? All right. Okay. New section, chapter 30.2. We're still on these guided notes here. Okay. So, chapter 30.2. We have two types of data, qualitative and quantitative, right? We're switching gears from the qualitative and we're going to the quantitative. Okay. Here's where we have numbers in our data instead of categories. Okay. 3 different ways we can represent these types of data. Okay. First one's called a line plot. Second one is a stem and leaf plot. And the third one is a little bit harder. It's called a histogram. We'll get into that a little bit later on Wednesday. First type of graph, line plot. Line plot is a graph that just shows the number of values for each number above the number. Okay. Now, I feel like a lot of people get this mixed up between like frequency charts and bar graphs. We can't use frequency charts and bar graphs if we have numerical data, okay? So that's kind of the difference between the graphs we did earlier this class and on Friday. Those were all categorical data where they could be described in words. These are all used for numbers, okay? So let's take a look at line plots. I'm actually going to unshare this screen because the video gets all tiny when I do it. Okay. So in this example, every student is assigned a number, and the number is listed below. We just want to create a line plot of a data system. Okay. So what we want to do is make a big line at the bottom of our graph. Okay, and this is going to be a number. I think we have to determine where this line is going to start and where it's going to end first, right? So what number do you think should start our number line? Yeah, 0. Good. I think I heard a 0.5. I guess we could do that, but in this case, let's just do 0 so we have a little space at the beginning. Where should it end? Yeah, let's do 5. We could do 4.5, but I kind of like having a little space. I don't take off points if we do that, but let's just do that. Okay. Now we have to figure out how many like increments we're going to have in here. What size increments do you think we should have? 1.5? 0.5, right? If we did 1.5, we'd be missing like 0.5 and 1 and things like that, right? So let's do 0.5. And I'm just going to pray that it gets to 5. We might have to extend this line. 1.5. 3.53. Or no. This is what I normally do. I just remake my line if I make it's too close. Too far. 1.5, 2, 3.5, 3, 3.5, 4. Now, if I really wanted to make this look nice, I would try to make each of these lines equally spaced apart. But since I'm kind of doing this on the board, I'm not going to do that. Okay, so let's try to make this line for oh gosh, line graph. Okay, we have a 0.5. So what I'm going to do, just draw an X above the 0.5. Okay. We have a 2. So I'm going to draw an X above the 2. We have another 2. Okay, that other 2 is going to represent another X here. Okay, we have a 2.5, 3 tenths. So I'll draw those at top. We have 4 3s, 2, 3, 4. We have 2 3.5s. We've got 4 4s. We've got 4 4.5s. And we have 2 5s. And what we've done together is we've made a line graph. Right? Very easy. We kind of just tally up how many times we see something. Any questions on constructing a line graph? All right. Now, just like the pie charts, sometimes we're going to be given a line graph and we're going to be asked questions about what it means. Okay. So let's take a look at this graph here. Okay, here we have a line plot, very similar. Oh, is it the same one? No, it's not. Okay. This line plot represents the student scores on math. So some people got 100, some people do as well. We want to see how many students' scores are recorded on the line plot. What I'm going to do here is I think I'm going to have you get together, work on the 4 questions. Okay, I kind of underestimated how long it takes you to go through these questions. Let's just go through the answers real quick. How many student scores are recorded on the line? Emma? 31. 31. And how did you determine? I counted out. Yeah, you counted out how many X's. 1, 2, 3, 4, 5, 6, 7, 8. So you should have gotten 31 for that one. What was the highest score? 100. 100. How do you do that?
I just looked where the farthest X's were, right?
Yeah, right. There's no more X's after this, so the highest score has to be 100. Okay. What about the lowest score? 40, right? Because that's the one furthest left. All right, got that one. How many students scored 70 or higher? Erica?
Yeah, 20.
20. And how did you figure that one?
I counted the X's starting at 70.
And did you include like this part here that included 70?
Yeah.
Yeah, right. Because it's 70 or higher, which means this group and like the rest of it, right? So when it asks for something or higher, you're including the one that says 70. Okay, so that one should have been 20. Oh, I think it was, did you guys get 20 or 21? Not 20. 20, okay. Yeah. Should be 20. What's the most frequent score? 80, right? And how do you figure that one out?
It just has the most amount of X's on it.
Yeah, it has the most one else, right? So 80 is the one score. So that one should be our most frequent one. Okay. Looks good. So I think next class we're going to start with STEM and lead plots. Oh, by the way, does anyone have any questions on these? Okay, I guess I'll let you out early again. And we'll start with these on Wednesday. Oh yeah, do you mind giving the protractors back? You don't have to put them in the Sorry. All right, and how about this? I'll make a file on the desk.
Thank you.
Oh, thanks, Ben.